So to get us started, I would like to introduce our first speakers. So we're in the digital technology driving an innovative approach to heritage preservation. So we've got Garon Deutsch, chartered engineering professional with demonstrated experience in inspection and durability assessment of infrastructure. Garon has a passion for heritage structures and currently sits on the Engineers Australia Committee. Caroline will also be joining Garon. Caroline works with URBIS Heritage Team as Associate Director. She's a heritage architect. She's also worked on emerging National Trust models of adaptive reuse of heritage places in the role of conservation, and has worked as a project manager from strategic inception to completion. And I'm sure that both of them will tell you a bit more about themselves as they come up, but please welcome them to present to you this afternoon.
Thanks, Mandy. Hey everyone, I hope you had a great lunch, and yeah, excited to dive into this digital session. Hopefully it can keep you awake, and yeah, we'll get some coffee after this. So what we will be discussing today, so we'll be looking at just a basic overview of what a reality model is, how we as men create these reality models, and then with Caroline we'll also then start diving into some case studies. So we've got Edmund College looking at their central block, and then we're also presenting on the Fremantle Port B-Shed. Caroline's going to look at some of the benefits of using these 3D reality models, and we're going to be very focused on structural heritage here. So I guess we're looking at something quite bespoke, but this could be kind of broadened to other heritage aspects. And then I'll also come back and look at some potential future uses, so a bit of food for thought for people. So what is a reality model? These are typically quite highly detailed and accurate digital representations of physical objects, structures or environments. And in the digital infrastructure space, they kind of sit between the original drawings, and then I guess as you go on, it kind of gets to more of an intelligent digital twin. These models are typically created using technologies such as photogrammetry or laser scanning, and they can be a powerful tool that can be used to enhance our ability to document, analyse and preserve the physical space and structure with detail and accuracy. We're currently seeing a bit of an uptick in industry, specifically around construction and engineering and asset management, and I guess we're here to kind of push this into the heritage preservation space. Some quick benefits which these industries are seeing. They're seeing accuracy, providing the precise measurements and a digital representation of the asset. Increased safety, so reducing the need for physical inspections, especially in hazardous environments. Efficiency in streamlining the process and documentation and the assessment, and also creating an archival record. So actually having a digital record that can be used for future reference and preservation. So we'll be kind of touching on these benefits more as we go along with the case studies. So I'm just going to present some types of 3D reality models. They kind of come in all shapes and sizes. The first one, which probably most of you are familiar with, are more the external 3D reality model. So that's on the left-hand side. So these are done with drone photography. They can be very large to very small scale. Very, very good resolution. And they can also have a very good relative accuracy of about plus or minus 5 mil. We also have interior 3D models. So similarly, these can be created with drones. They also have pretty good resolution, 2 millimeters. Because of the environments that they're captured in, they're typically poorly lit, so they do suffer a little bit on their relative accuracy. But they can, I guess, showcase the internal condition. We also have 360 walkthroughs, so these are simply just with a mobile hand scanner, creating a point cloud, and then they take 360 images as you go around, so kind of like a street view that you might be familiar with Google. These have kind of quite a variable range of resolution. So you can go down to 1 mil, but typically they're a lower resolution, and therefore their relative accuracy kind of suffers, so you kind of get down to that plus or minus 30 mil. We also have underwater 3D reality modelling. So these are done by ROVs, and due to kind of the poor visibility with the water, they have to kind of be captured very close to the structure. So you still get a pretty good resolution. Again, your relative accuracy kind of goes down. But the cool thing here is you can also put in different payloads of the ROVs, so you can input additional data to these models, such as cathodic protection testing or thickness measurements of the steel if you're looking at a steel structure below water. One thing that we kind of specialise is on water reality models. So we've designed a drone boat which takes a multi-camera rig and a SLAM LiDAR payload. So we typically use this for soffit wharf inspection type work. Basically where anything that has like a small space clearance. So we're kind of working in about that 0.5 of a metre clearance zone. Get really good resolution with this. Obviously the cameras are very close to the surface. And we also get a pretty good relative accuracy, similar to the other drone images, so plus or minus 5 mil. And the other thing, we can look below water with bathymetry surveys, so you can overlay bathymetry data using multi-beam echo sounders. These kind of just get a point spacing. We kind of work at about 44 points per square metre, if that means anything to anyone, and about 8 metres of depth of water. With these, you suffer in that accuracy, so you're now down to like plus or minus 100 mil for measurements. And that's kind of in the best case. So that was a brief overview of different types of models. And then we also have to think about how we give this data to people. How do people actually access it? How do the clients use it? How's it going to be viewed? How's it going to be shared? And I've kind of broken into 3 kind of ways that I can kind of see these models getting delivered. So there's a simple cloud-based model. This is quite easy for people to access. You know, it's a simple share link to a URL. It's online. Somebody hosts a model. They manage the data, but anyone can use it. And that will be kind of what we will be case studying. And I'll be showing some snippet videos in a second. The other one, if clients are a little bit more needing their data to be secure, you can also offer an offline kind of desktop application. So they host the data and then they can share things relatively from there. They can also kind of richly feature this spatial data with additional layers. So they can put in BIM models or CAD data. And then the other one is kind of leaning towards more your digital twin space, where you kind of provide an enterprise solution. So these integrate and centralize heaps of data, so you can have, you know, Internet of Things, you can have sensors, what things used to be, you know, statements of significance linked to certain elements. And that's kind of the Rolls-Royce solution. And kind of, I guess, where the 3D reality model kind of becomes that centralized point of truth for hosting all that data. So I'll now pass over to Carolyn, who will present our case studies.
Do you want to run the film?
Yeah, sure. I'll talk over it, so you maybe just introduce it.
Hi everyone, thanks for listening to us today. Garon and I have worked together on a couple of projects with digital technology, and so we thought, Garon asked me if I'd like to share a couple of the URBIS projects. They're very high level, front end feasibility level of work, and so we thought we would share Edmund Rice with you first of all. And Edmund Rice is, it's state registered. It was Catholic Agricultural College until 2018. We were working on 4 conservation management strategies for the client, and we struck a problem when we got to the central block CMS, because there's lots of inaccessible roof areas and it's a very large building. So we thought about using a 3D reality model to capture inaccessible areas. Garon's just going to run through the drone footage and then we'll get back to it.
Yeah, so this is the central block here. So you can kind of see the resolution that we can capture on the stonework. And as Carolyn pointed out we had a bit of accessibility issues with the roof, so there was quite an importance to look at the roof condition. So here's kind of looking at the cupola up the top, and you can also, with this image viewer, look at the original photos that the drone captured, so we can get additional detail here as needed for that condition assessment work to formulate into the conservation management strategy.
Part of the beauty of the model is that we wanted to see if we could extract elevations, and while the CMS didn't need us to draw elevations, we got some 2D elevation images of the model from MEND, and we put them into AutoCAD, and you'll see from the white lines on the page that they're straight and true images with a lot of render detail that you miss out on trying to just draw in black and white. You can see that it's quite straight, quite scalable. That potentially provides time savings when we want to convert our work into AutoCAD. This is not moving on.
Just hold it up. There you go.
Okay, here's some more elevations. You'll see the different file sizes that went in have got different levels of resolution. So the 3mm image, 820 megabyte image, but we're just using it for tracing purposes. There's also a 7mm image, which is 362 megabytes. So they're quite usable, in fact. And here are the other elevations. So from the model, we can then convert back into 2D with a simple trace if we wanted to. We also could populate our roof plan with condition reporting and recommendations for prioritised works. Okay, we're on to the next case study, which is B-Shed in Victoria Quay. We were commissioned to do some high-level feasibility work, and it's a very repetitive structure with 35 timber bays of trusses, and it's a large volume inside. So for one site visit, it's very difficult to capture high-level detail of all these trusses. So we were quite keen on getting an interior model that we could then refer to. I'll just let Garon show you through the model.
So this one, we have a mixture of exterior model, which was captured at quite low resolution, and then we actually move inside the building. We did an interior model for this one as well. So, obviously you can tell that this provides great context to the building, and there's also going to be a snippet that shows the draw tool, which you can actually take very accurate measurements. So you can take measurements of beams, columns, you can look for clash detection, potentially workshop adaptive reuse solutions. You can drop things in this space as well to kind of visualize it. So yeah, great tool going forward.
You'll see that there's a little bit of modelling in the model, so it's not perfect, but you will see that you can refer back to the photographic stills, which is in the centre of this image, which gives you a higher degree of resolution. Jane told me that the reason for the modelling is just interplay of light and shade using a photographic 360 virtual walkthrough technique. So the benefits of having this model include being able to quickly go to, say, structural frame number 17 and then being able to identify original and repair fabric. It also saves us time because of that, rather than going through 900 photographs and trying to find the right place. On top of that, it's an asset management resource for future investigations, and it will provide more efficient and accurate information for construction documentation. We couldn't get up as high as we needed to be able to record these trusses and the changes that have been made. So we're looking forward to getting back with the model in future stages. So from our point of view, the benefits of having the model are we can get to inaccessible places, provide safety for our consultants who shouldn't be walking on roofs that are treacherous, and there's no access to a lot of these heritage buildings, as you know. We can also eventually start tagging the conservation works within the model, and I'm quite looking forward to the day when we're all able to work with models for our documentation. As you know, there's a lot of detailed condition information in a big place, and this retains detail while enabling speedy and quick accuracy. In a sense, they're going to help replace some of the traditional surveying because we can use these models without necessarily having to pay for a measure up of the building because we've got a scale model. It also might provide an archival record if we agree in the future that this is sufficient archival technique, and that raises its own questions about user platforms, but it's also enabling a wider group to be able to look at the building that wouldn't otherwise be able to. Thank you.
So yeah, that's kind of the two case studies that we wanted to present. I also thought I'd throw up some more literature review of potential future uses so you guys kind of can think of, in your sphere, what you could maybe hope to achieve or what is accessible now currently. So just looking at more the digital engineering and capture. So we kind of see benefit in this where we can track changes over time. So you can repeat these models as much as you like, and kind of like I don't know if anyone uses Near Maps or Google Maps, but you can have a time slider where you can actually see these changes occurring, which can be really handy for our assessment. Similarly, you can do damage assessment. So, your early identification of some of this deterioration that's happening and get onto it quickly as a bit more of a preventative maintenance solution. There's also AI in this space that is starting to detect things like concrete deterioration, corrosion, so you can pass these models through these algorithms and they'll start pinning you to areas that are of concern and might need a further look. As we kind of touched on as well, I see this as a very useful tool to preserve the information. It's typically a lot easier to preserve data than the structure. And if anything, worst case scenario happened to this structure, at least we have a record. And we're seeing that, there is kind of that change of thought that I know my time in Sydney, that there was the Sydney trains were using these to capture some of their assets and actually documenting and starting to store this information because they were aware that some of these bridges and things weren't going to be able to be preserved into the future. And then also, I guess, a cool thing is that the drones are teaching the drones. So as a non-destructive approach to inspection, one time you've mapped it, you can actually then use that data to inform the next inspection. So limiting any kind of destructive access methods that typically would have had to be used for these areas. And then I guess looking at more of a virtual restoration, VR, AR capabilities. So we can use these models or we can render additional models to show what once was. So if anything did get to be demolished, we've got that preserved data. We can then kind of create an experience for visitors or locals of what used to be there. I guess an interesting one that we saw this morning with the Sydney First State Building. We could actually have a projection in the museum of maybe where it was on its foundations. We can also picture these structures or places in a different context. So, over these thousands of years, the weather's changed, sea levels have changed. We can actually project that type of event at that time on that site for visitors or for the locals as well. And we can also finish the unfinished. So obviously there's some structures that never get finished, and we can actually project what should have been without actually needing to do anything to the structure itself. Three more that I'll touch on before we go to questions. So AI is also getting into identification of heritage. So we can pass this photogrammetry through algorithms, and we can actually start classifying some of the elements and matching that to its significance. So that's a pretty exciting space. There's also AI that can be used to create better records for the future. So kind of like what we touched on, you have the model as a base, but you're creating those additional BIM models or floor plans or 2D elevations. And my favorite is the material analysis part. So there was a project where they used deep learning segmentation and coupled that with XRF and XRD analysis, and they had actually informed the conservators how to fix up a wall mural, so what materials to use and in what sequence to put that stuff back. So yeah, so that's some of the future stuff. We'll open the floor to questions. Thank you.
Just a minute. Just a minute, I've lost the questions. Hannah? We'll take a question from the floor and then I'll get Hannah to get us back online.
Look, thank you for that. I'm afraid that you've kept me awake, which is a very dangerous thing to do after lunch, so thank you very much for that. I just wanted to ask you a little bit about two statements that you've made and ask you about your solutions. One of them is that data is easier to preserve than buildings. And the other is that you're going to be creating better records for the future. So could you talk to us about your sort of digital obsolescence, your issues with digital obsolescence, the digital standards that you're using, and who in the future is going to be able to use that data if these things aren't addressed? Thank you.
Yeah, it's actually an interesting point. In the Engineering Heritage Conference that we held in Adelaide this year, this got brought up as a big thing, and I think archivalists are really trying to wrap their head, and they're starting to get so much different format of data coming through their doors and how they're going to deal with this. It's not my space of expertise, but I think my general solution to this is trying to allow data to be kept at its rawest format. We shouldn't be reliant on any particular software into the future. There's always software that gets superseded. So then as an archivalist, you've then got to make sure the software is up to date to read the data. But if you keep the data in its most rawest format, there should be a way to, like we create these models with current software off very basic raw data. You should be able to do that into the future regardless of what software is chosen. So if you keep the data in its raw format, you should be able to replicate that into the future.
Great, thank you. I've also got another question. Can you actually recreate buildings that no longer exist from photos?
Not from photos, but you can from any archival document. So if we have floor plans, we can then build up a BIM model, and then you can kind of render those back with things that you know. So I guess the more information you have available, the better a model you can create, is probably my short answer to that one. Do you want to?
Okay, terrific. Another question, is this something that could show old townscapes where mining has taken over? So South Greenbushes or Golden Mile have been given as examples.
Yeah, for sure. If you've had the historic records, and you can build anything. It just takes resources and time. So, yeah.
Okay.
I have a question, actually.
Oh, another question.
I have a question. I'm not a digital expert. Can you explain the difference between point cloud models and what these virtual reality photographic models are?
So point cloud's just created with laser scanning. So basically you put a laser scanner in and it shoots a bunch of lasers out. You get the point clouds back. What we create with the reality model is more photogrammetry. So you're creating high resolution imagery. And then you basically use aero triangulation and GPS coordinates to look at where individual photos were taken. So in the Edmund Rice snippet, you would have seen all those little green triangles within the model. They're all the individual photos that we use to create the model, so they get all stitched together and kind of create that rendered facade.
Great. Another couple of questions that are related, so around the cost effectiveness of the method. So how cost effective is this for small scale local museums? And perhaps a way to ground that might be to talk about the costs attached to the types of projects you've case studied.
Do you want to start and then I'll... Or do you want what would it
I think without quoting prices, you could say under $10,000 would get you a range of services for one of the projects. But I'll pass on to Garon, as he's got more information on that.
Interesting with the museum space, because this technology is getting more and more accessible. So if you've got an iPhone Pro now, you can create 3D models simply with your mobile device, and there's freeware that you can purchase on the App Store to do that. So if you've got small scale objects, it's basically free. It's just time. For the higher resolution building models, where you're kind of sitting in that kind of thousands, and then there's a rough rule of time on site is roughly 4 times the effort to create the model. So the drones are typically quite automated now in their capture plan, so you could probably capture a building in an hour of flying, and then there's probably 4 hours of actually modelling that needs to be done by a specialist. So they're very cheap, and they're getting cheaper. Obviously, technology is getting better and better, and there's more hobbyists in this space as well. So I would employ anyone that has an iPhone Pro to download that and have a capture of museum objects, because it's quite simple and quite effective.
Thank you. There's something to do on the weekend. And you might not be able to answer this in definites, but just a question around how many hours of flight time was required to gather the data for the Edmund Rice building?
Yeah, so we flew that in about 3 hours. One of the limitations at the moment with drones is battery life. So you're obviously cycling batteries often. That's probably the only consideration for these types of jobs, and being Bindoon, we're kind of rural, so you kind of got to make sure you're not having to revisit. So you're taking extra precaution to capture that data while you're there. So 3 hours of that whole building. So it's not half a day, including travel time. It's not too tough. It was 40 degrees though while we were there, so that was a challenge.
Okay. Any other questions before we wrap up? Yes, can we have the microphone? Thanks, Hannah. We'll just wait for the microphone, thanks, so the people online can hear.
Thank you. Do you see yourself having to put any sort of parameters on?
On the web, not so much. So we kind of host on a particular platform. I think the stuff for clients, and especially we work a little bit in the defence space as well, is more about who's hosting. These clouds are hosted by multinational companies.
I'm asking because of the current trend, which seems to be towards research by remote in some universities, and the potential for the misuse of material like that you're displaying. I know from first-hand experience.
Yeah, data storage and security is a huge topic.
I just wonder whether it would come from you, or whether you might put something on that says if you are using it for this purposes, then it will be for your institution to establish the parameters under which this material is used.
Yeah, there's new laws just got in place as well about managing this type of data for asset owners. So there's essentially an obligation to us to hand over that data back. So it becomes a responsibility of the asset owner, which it should always be. Any asset owner should probably not be reliant on another company to host their data.
But if it becomes a bit of a spider's web and you're trying to identify who actually owns the asset, it becomes a bit complicated and messy. I just wondered whether there was an easier way, a clearer way of doing it and establishing some sort of a process, so it's not hit and miss.
Yeah, it'd probably be sorry.
No, I was just going to say, I think there's another question's come in similar in terms of who owns the data and then who's responsible for preserving the data.
Yeah, so the asset owner owns the data. I guess it depends on the commercial agreement of who's doing the work. We typically pass it back to the asset owner, but I can't speak for everyone doing this type of work. I know that there is some issues with some companies that are holding data and not, I guess, they're owning the IP and they're not releasing it back to the asset owner. That's a whole kettle to unpack. And then I think what I was touching on with the defence space, but also then if this data is going to another country and it's infrastructure that's critical for other people, who's then kind of looking at that. So definitely something to be wary of if you're in that sensitive space.
Great, thank you. Thank you very much. We'll wrap up with a hand of applause. Thank you.